G'day, I'm 𝗟𝗏 𝗠𝗏 from Agentics New Zealand, part of the Agentics Foundation, a not-for-profit dedicated to making AI innovation and education open to everyone. Tonight we held our first show and tell session, aka lightning talks, where we got a little taste of some of the wild stuff the growing community of agentic engineers in New Zealand has been cooking up. The format for the lightning talks is around 15 minutes for presenting, with Q&A after each presentation. The hot topic at the moment is running local models. We have special guests from HP taking us through their awesome AI offerings, and then a guide to getting started with local models from Jay, followed by an outcome-driven AI for human change discussion by Arjan, and finally an AI-driven test framework from Manish. So buckle up and enjoy the talks.
Go ahead.
All right, so I'll go ahead and talk to everybody about what cool things HP is doing with AI workstations and solutions. And if you don't have access to 40,000 GPUs like OpenAI, maybe we can help you.
Thank you. It's gone again. He's back. No, he's gone again.
Oh dear. We've lost you again, Lenny.
How about now? Can you hear me now?
Yeah, you're back.
I tried the fancy microphone. We'll try the laptop's microphone now and see if that can.
Laptop, you're loud and clear, Lenny.
All right. Let's see if I can get to the first slide now. All right. So when we think about HP's workstations and AI workstations, really what we're talking about is powering through heaviest workloads. And these are the workloads that, like I kind of joked to, you can't put into the cloud or the data center. We may not have access to 40,000 GPUs. We may not need all of the information on the entire internet, like ChatGPT. Maybe we want a more specialized model for something that we're specifically doing, and maybe even trained on our data. And an AI workstation is perfect for that. If you want to bring things down locally, prototype, experiment, use retrieval augmented generation, these heavier workflows that can be done locally can be done on our workstations. The advantage of these workstations are definitely power and performance. So we'll talk about some really cool technology that we put in there. I think the big player, the big name that everybody thinks about when we talk about AI is NVIDIA. And we do have NVIDIA's latest and greatest graphics cards within not only our mobile workstations, but also our desk side workstations. But NVIDIA is not the only player in the game. AMD is also making some big strides as well. So we'll talk about that as well. And that's one of the advantages of HP's AI workstations is we're not a one-trick pony. We'll have several different configurations, several different sizes, several different types of technologies to match the tasks that you need the workstation to accomplish. Security and reliability. Security is built into all of our workstations from the BIOS on up, but also bringing things local or doing some things local also present a more secure security posture when you're talking about people's personal data or intellectual property on a really cool idea or something that you're trying to get. Having control of that data, having control of who has that data is, definitely something to be, concerned with. Reliability, our workstations are known for their reliability, and each one of them goes under just under 300,000 hours of testing before we launch it to our customers. So you can rest assured that it will be reliable, and our workstations last for years and years and years, being turned on and running the entire time for years and years and years. That's what they're built to do, mission critical. We have several ISV certifications and partnerships with a ton of software vendors that are out there to help make sure that we have the right technology and the right technology tuned to perform while doing all of these tasks. And then, like I said, our computers are meant to run for years and years and years. So we make sure that the technology that we're putting in there can stand up to years and years and years. So you're not behind in technology after 1 year. So see, these are some of the segments where we see our AI workstations being very popular, and some of the workflows within these segments that are really being accelerated with our workstations. So our public sector folks are using all kinds of stuff, generative AI, recommendation engines, computer vision, data analysis and visualization. And also what I see, at least here in North America, when I work with whether it's local governments or federal governments, the big thing now is real-time decision-making, and how generative AI, data analytics and visualization can help decision makers make decisions in near real time. So think about in an emergency situation, a hurricane, tornado, weather, fire, something like that, being able to use AI in real time to make life-changing decisions is something that we see more and more people asking for. And that's another reason why you would want to bring something to the edge, is to remove any latency. So computer vision, think of like security and airports and things like that. If I'm using facial recognition and I have to send that off somewhere and wait for an answer to come back as to whether or not that's a bad person or not, they may be 3 blocks down the road before I get that answer back. And that's where local AI is really important. And I make that joke, but that's actually, in my 13 years at HP, that use case is the very first AI use case that I did. And that was to prepare for the Super Bowl in Minneapolis, Minnesota. And I helped them to up their security in the airport there for that. And just to throw some numbers and to put this into context, they have a little over 3,500 cameras that are all 4K and do pan, tilt, and zoom. Could you imagine the size of cable they would need to run that to the cloud? Yeah, it's huge. They used our workstations instead and took advantage of real-time analytics, real-time decision-making, and saved a whole bunch of money by not having a giant cable going into AWS. So the future ready is differentiated hardware as well as our solutions and innovations. So let's talk a little bit more about that, and I'll try to be quick here.
Yep.
So like I was saying, even within our mobile workstations, our higher end notebooks, these are built for AI consumption all the way up into development. And as you're doing more with the computer or need more horsepower, we definitely have, you know, the ZBook Fury on the right here is meant to be a true desktop replacement. So our higher end users that need desktop on the go, we have something for that. But probably our most popular unit, and the one that I would really look at right now, is the ZBook Ultra, which is a 14-inch notebook, which is thin and light, but can have 128 gigabytes of unified memory. And this is by AMD. So both the CPU and the GPU can share up to 128 gigabytes of memory. You can dedicate 96 gigabytes to the GPU and kind of do that on the fly. So as your workload needs like more serialized stuff, you can put more RAM towards the CPU. If you need to do more parallel processing, then you can put more RAM to the GPU and do that in a thin and light notebook. And this thing is super thin and super light. It boggles my mind that they can put 128 gigs in such a small laptop and have it actually run. It is impressive that they can do that. So I like to highlight that it's not just NVIDIA that's making innovations and everything in AI and data science. It's important to look at what Intel, Microsoft, as well as AMD and what they're doing with things like this unified memory. Similar to our notebooks, we also have a full line of desk side workstations that also can have Intel, AMD, as well as the NVIDIA graphics cards in there. Similar situation as you're doing more, we have workstations that can accomplish that. The one on the very right here is my favorite one of all, and this one can have 4 full-size graphics cards in it. So you can train really large models of, more than 400 billion parameters on a local workstation, which is pretty insane to do. The other one to look at here is the bigger brother to the notebook from AMD that we were talking about, and it's Z2 Mini G1A, which is a small desk side workstation that has that same 128 gig of unified memory. So another game changer, another innovation from AMD within this as well. And here's a little blurb on that, and it is super small. One of the biggest benefits of this is its power supply. So it's like power brick. You know how every electronic component you get these days, they make it super small, and then you have this giant block on your power cord. That's included in this. So you just plug the cord into the back of it, and you don't have a giant brick on the back, and it still has a small footprint with that. And then another really cool thing that we're doing is a technology called HP ZBoost. And what this does is, say you have a really thin and light laptop and you want to use a GPU that's on your network somewhere to train a model or render in CATIA or something like that. With HP ZBoost, you can actually do that. And this is really transforming the future of advanced workflows. And we're doing a whole bunch of stuff with this. And as you could imagine, to be able to take an underpowered computer and make it super powerful for the time that it's needed to be powerful is a huge benefit. I can tell you, when you're investing in technology, and we're starting to put some math behind this, and I got some really smart, distinguished technologists backing me up on this, but the best way to get ROI on any of these investments that you make is to make it available to more people for a longer period of time. And when you think about that, that kind of makes common sense. Well, yeah, if some people can use this more, then obviously I'm going to get that return on my investment for this hardware a lot quicker. The challenge becomes how? How do I make this more available to people? How do I make it easy for people to use? And how do I, put the hardware in the right people's hand? Technology like HP ZBoost helps to do that and helps to maximize the ROI on the AI investments that you're making by allowing you to provide that technology to more people for a longer period of time.
Hey, Lenny, this is awesome, and I'm going to give you a 2-minute time check, and then we'll go to some Q&As.
Okay, I'm like 5 minutes away, and I'll be done. So let's take a look at that in action. So as you can see, one of the final steps for people when they're designing things is to render it and to put it into life to where the rest of us can kind of see this. And you can see a 4.5-hour render down to 46 minutes is the kind of boost that we're talking about, and the boost in technology that we would be talking about. And that's something really, really cool, and only something that HP does. And then last but not least, our very latest piece of technology is called our ZGX Nano AI station. And this is a tiny little box, but packs a major punch. So in 150 millimeters squared by 51 millimeters thick, which is smaller than all of those other workstations that I showed before, this has a Grace Blackwell NVIDIA super chip in it. So it has an ARM processor and a Blackwell GPU and 128 gig of unified memory. And this is a companion device for AI developers and folks that are inferencing. This little box has 1,000 TOPS. A TOP is 1 trillion operations per second. And this one little tiny box has 1,000 TOPS in it. So when we were talking about the AMD Ultra G1A, that has 50 TOPS in it. And most AI PCs are 30 TOPS to be an AI PC or whatever. And this little thing has 1,000 TOPS, and you can actually daisy chain 2 of them together. With this, you can train up to 70 billion parameter models, and you can inference 200 billion parameter models on this tiny little device. And as you can see, this is kind of where it stacks up with one of them, 200 billion parameters and 400 billion parameters. So as you can see, an extreme amount of accuracy for inferencing, and 70 billion and 140 billion for fine tuning is a pretty large amount as well. So as you can see, as far as AI, local AI and workstations, there's a ton of innovation and a ton of technology that we're putting in people's hands to help develop and to help use AI to make things better and to make everybody's life better. And that's all I have.
That's awesome. Thank you so much.
Is there anything I'd be happy to answer?
Any questions from the floor? Just chuck up a hand and we'll take questions. Go, Jay.
Hey, thanks very much. When do we expect this to be actually on the retail market in New Zealand?
The new one, the Nano, so it actually went into production last Friday.
Okay.
I believe for New Zealand, you're looking at December, January timeframe when units will be available down there for the Nano.
What about the G1A?
Oh, go ahead.
What about the G1A, the Z1?
Those are shipping today. Both of those, the notebook and the desk side, are shipping today and are readily available.
Thank you.
Sweet. Paul, what are the do you have the recommended retail on those units?
No, it's a very hard thing to. We typically at the more enterprise type pricing, and there's government pricing applies to them. So I can say, oh look, that depending on the configuration you put together, it could be okay. But with the discounts and the government and the enterprise thing, suddenly you might be at 4.5, 5K for it. It's very much by, if anyone's want that sort of thing, reach out, give us an idea of the specification, and we'll put something together.
So Paul, you mentioned we might be getting our hands on some of these for Agentics NZ. What units did you have on offer?
2 in particular, Chris. A couple I actually mentioned to you, and I detected a good reaction back. And so one is the it's the two that Lenny has sort of highlighted there halfway through the presentations. One is the notebook, and that is the ZBook Ultra, and then we've got that configured up with the 395 AMD processor, basically about 128 gig of memory.
Yep.
I think it's got a 2
Wow.
terabyte drive, etc. And the other one we've gone for is the small Z2 that Lenny talked about there.
That guy, yeah. Awesome.
And figuring that up to the max, and I think on that one I've configured it with a 4 terabyte and a 512 to stick the OS on, so you don't have to split the drive at all. So that's what we're working on getting through. We're just working with AMD and our internal people just to see how quick we can get that organized. And we typically, it's around 3 weeks is normally the type of order to delivery cycle. As Lenny said, they're readily available now, and because it's built to order, not just an off-the-shelf product.
Yep.
Typically it's around 3 weeks.
Oh, fantastic. Oh, well, gosh, we'll have to figure out how we can get access to the group for these. And that's something that I'll be talking to you guys about in WhatsApp. So get in there and we'll talk about it.
And when you get them, Chris, we make it so that they will come with the Microsoft, the new high-end operating system, but we've got the data science stack ready to go. It's freely available, and that gives you a number of different products you can easily pull down and install.
Oh, nice.
So you don't have a lot of setup time. You can get all that favorite tools that you like to work with. We just thought we left that out for now. We thought it was something we can come back and address at a later point.
Sweet.
But
Awesome.
I think very much for us, the focus has been on the internal, because we're seeing a lot of customers from a security perspective, latency perspective, a sustainability perspective, in that, you know, it's not chewing up all the power. They're very efficient, lean and mean.
Yep.
And then from a cost factor, you know, up in the cloud can cost you 5 times more than what it would cost you to do it in-house, when things is just a rough number that gets bantered around at times.
Okay. Well, gentlemen, we are very, very appreciative for the very kind offer, and thank you so much, Lenny, for coming to us at an ungodly hour from the States today.
Not that bad.
Much appreciated.
Thank
And,
you everybody for having me.
Yeah, you're welcome to hang around, both of you, and we'll move things along now. I'm just going to chuck the agenda into the chat. So there is an agenda and everything. So we've just heard from Paul and Lenny, and Jay, you are next on the list. Have you got something to talk about today?
Yes, I do. Let me just try and share my screen. Let's see if this works in one go. All right. Okay. Hey, thanks everybody for making it. I obviously can't see any of you because the whole presentation is taking up my screen. So if you have questions, we'll take it at the end of the presentation. Chris, before I start, how much time do I have?
I'm starting your 15-minute clock now.
All right. Okay, cool. Thank you. All right. So
I'll give you a time check at 10 minutes.
Okay, that's cool. That should be fine. So I just wanted to just do a quick presentation on getting started with local models. I know some of us have been playing with it, so some of this information might be known to you, but some of us might be very new to it or have questions about certain things. So this will start with the real basics, and we'll talk about a few things that are very commonly used in terms that you would really hear on the regular, but you might not know what they really mean. So I'll just demystify that for you. I'll also run through a list of hardware options, what you can use to run local models. We'll also look at certain tools that can be used to run these local models. And I'll also show you a snippet of what happens behind the scenes when you run a sizable model. I've done that on my laptop, which is not like super powerful, but yeah, it still had some juice to get through. All right, so let's get started. Okay, so the very first thing is LLMs. What are LLMs? LLMs are large language models. So it's basically a neural network that is trained on massive data sets, and it uses a transformer architecture to understand and generate human-like language, and then it is something that can predict what can be coming up next based on the query that you put in. With LLMs, there is also something that you really hear very often, which is tokens. Tokens are the smallest unit of text that AI models process. You can consider them to be the basic unit of text processing. And this is usually broken out into commonly used phrases within the human interactions. So in some cases, one word might be two tokens, whereas it can just be one single word. So there are certain things that play into this as well. We'll look at it later on. The next thing is vectors, which is very important. So vectors are basically a representation of data. It would be text, images, videos, whatever you're working with, which are all similar to each other. So if you have like three words which mean almost the same stuff, then all of them are placed within one vector. So that's how the LLMs actually work behind the scenes. They use these vectors to group things, and they know what's the closest thing that you are talking to when you're referring to a particular word or term. So it's just representing meanings and how far they are from each other. Based on the distance and the weightage, then you get an answer based on how good the score is. Then there is the last bit, which is the real world uses of LLMs. And it's not just LLMs, we have different types of models as well, but just generalizing it here. But that's the general application at the end of it. Let's take a deeper look at what these are actually. Like I mentioned, LLM is a neural network trained on massive data sets. And its key feature is to understand what human generation or language is, and then respond to it in a way that we can understand. So it runs off of the data that we feed it when you're training the models. So you can use this for pretty much everything, like chatbots to code generation. There are now better versions of these models which can do even more. They can create videos, images, renders, like we already saw in the previous presentation. But the LLMs do have a negative. They do have biases that are built in based on what kind of training data you put in. So if you put in the wrong training data or compromised or malformed training data, you will get something that is not very desirable. Next up is tokens. Like I mentioned, that's the smallest unit of text that the LLM uses, and these tokens and how these tokens are processed really affects how much it will cost for you to run a particular query, what the processing speed is, and you're also limited by the context length. The context length is basically the whole length of the query that you're putting in. The good thing is this tokenization breaks it into manageable pieces. So then based on the kind of vectors you're using and the path that is taken, you will get a best placed answer. Pretty much how all the models really work. And like I mentioned, vectors are used. So vectors will group similar meaning words into one vector. So if your word is in that particular vector, then that gets a higher score. So it is it is probably n-dimensional, not just 2 or 3. A vector can be n dimensions, and the more complex models we use, the more complex these vectors get. Not a topic for today, but just something that you should know. All right, what are the types of AI models and applications? Of course, this does not include everything because we are short on time, but I'll talk about a few things. SLMs. SLMs is small language models. They're compact versions of LLMs, and what you do is you create these models just for a specifically curated data set. So, for example, within an enterprise, you create the SLM, which is dedicated to your enterprise by training it on data that is primarily yours, for example, your documents, etc. So it will really talk only to whatever your specific purposes. But the advantages are that it's much smaller in size. Usually, a large language model is probably in the billions of parameters. So a parameter is probably just the basic amount of data that you use to train your model. So a billion parameter model is that many data points that have been used. So a small language model will have probably a few million to a few hundred million parameters, but it's still very good, specifically if you're looking for your own enterprise and your own, what should I say, air gap model, which nobody else will have access to. So it's got specialized applications, and in quite a few places this will be very good use. Then you've got something called as GGUF models. You have seen this on pretty much all the model hosting websites. So it's GPT generated unified format. So it's basically a format designed to make AI models easier to run locally, because you kind of have a compressed or a more efficient image, and it's going to be one single self-contained image of your entire model that's going to be there. So GGUF models are known to be efficient because they can run locally and they're smaller in size, and they're all a lot more faster as well. So your inference costs or your running costs that are there, that's going to be very less. And if you want to be trying out things, you can try out the GGUF models on your own laptop or your own machines in case you can't run like a 235 billion parameter model on your machine. It's also widely supported by pretty much all the tools. You've got compatibility across the board. So it's very popular. And I also use a couple of GGUF models myself because I don't have such a powerful machine at my disposal yet. Then we've got something called as reasoning models, which is OpenAI's O1 models, which is specifically used for STEM processes, etc. It uses chain of thought techniques and reinforcement learning to actually get its reasoning capabilities. The last one I want to talk about is multimodal models, which gives you multiple data types to work with: text, image, video. You've got encoders, and you have advanced applications. Again, not something we're delving that deep into today, but something you want to know. If there's time, I'll talk about mixture of expert models as well, but let's get through this. There are certain things that you need to know about optimization of models. So the first one is quantization. So it's basically a process by which you convert high precision numbers to low precision formats. So it will thereby reduce your computational and memory needs. And there are various levels of quantization as well: Q3, Q4, Q8, etc. So it reduces your model size, lower precision, but faster inference, but you'll still get reasonably good results. So your results might be 80% of what the full-size model might do versus a quantized model, but it's generally okay for all the purposes that you would use on a daily basis. We've talked about RAG, retrieval.
It's 10 minutes, Jay.
Yep, that's good. On track.
Cool.
So RAG is basically enhancing LLMs with specific external data. So it gives you a more accurate answer for the kind of data that you are looking for. So consider this to be a bigger version of SLMs. But heads up, RAG is already out of the way on the AI industry because of all the developments that are happening. Context engineering is building comprehensive AI environments by providing context and structured dynamic data. Then you've got Model Context Protocol, which is a protocol that was introduced by Anthropic in late 2024. It's got a client-server model, so you use that to actually get additional sources of data and use that to enhance and better make your quality of your answers better. And this is probably where we're going with the future of AI models. Then you get agents. Agents that we've been talking about, they're autonomous systems which combine LLMs, memory, advanced tasks. It actually does multiple tasks and handles different use cases. Conscious of time, we'll move forward. Some hardware essentials. Compute cores. This is your individual processing units that actually perform your processing. The more number of cores and threads, the better it is. TDP. It's the amount of power that is actually taken and is measured in watts. It's basically the heat that is generated by the processing unit, and that will give you an indication of how much power it will use. GPU is your graphics processing unit, which is specialized for parallel calculations, and it comes with multiple cores, like Lenny talked earlier. Then you've got VRAM, which is the video RAM, which is fast and temporary storage for your GPU. So you can transfer stuff from your main memory to your GPU so that you can have it there. Then you've got unified memory, which is the new architecture for the AI PCs, where you've got one single unified memory, which is shared between the CPU and GPU, and the demands are met on the fly, or you can pre-configure it to any number you want. Usually on 128 GB shared memory units, you put 96 to the GPU and the rest to the CPU. The last bit I want to talk about is the memory bandwidth, very, very important, which is the speed of the data transfer between the memory, your RAM, and your processing units. So this actually determines how much of threshold and processing you can actually do, because even though you've got 64 cores, if you've got smaller bandwidth, you can't really make use of the cores because you can't send and receive that much data. What I've done here, I want to go through this whole list. I've compiled a list of popular graphics cards and other AI mini PC units, and I've also put in the ones that Paul and Lenny talked about today, with their memory bandwidth and what their AI software ecosystem is, etc. Generally, on the NVIDIA side, the AI software ecosystem is much more mature. AMD is growing. Intel is very limited at the moment. But yeah, you can go through this. I'll share that later on. All right. Now coming to the most important bit. This is all just so that you get to know what is what. For running models locally, you need to assess your hardware, choose a model that you can run on your machine, try GGUF models if you want. You can try larger models also. You're not going to wreck your machine. The max that will happen is the model won't load or it'll give you an out of memory error, so don't fret too much. What are the tools that you can use to run models locally? LM Studio is very popular. That also comes with a user interface, so it makes it far more easier for you to run a model locally. Ollama is another one, which is just the command line interface. It's also very powerful, but it's on the command line interface. So if you don't want a GUI, you can use Ollama. There are some things that you can do with an LM Studio which you can't do in Ollama, but yeah, I'll leave that up to you. Links are all present on the resources slide. So what have I been doing? I've been running models on my machine. I've got a gaming laptop, but it's pretty good. So it's got a 8-core 16-thread processor. It's got 24 GB RAM and 6 GB video memory. It seems minuscule with comparison with the current AI PCs, but they're like a 6-year-old laptop. So for that, it's still doing pretty good, because I was able to run a 20 billion model parameter model using LM Studio, and I got a output of about 7.5 tokens per second. You can run smaller models as well. For example, the 𝗟𝗓 4 billion parameter model. This one, I got an output of about 30.16 tokens per second. So if you want, you can try these models out. If you want, you can try other models too. All of them can be accessed via LM Studio and Hugging Face. I'll include resources in the resources link. Just to show you what happens behind the scenes, when I ran the 20 billion model, this was the CPU usage and my GPU usage and memory usage. When I ran a 4 billion model, you can see the usage is far lesser and the memory consumed is also lesser, but the GPU is still high because that's where most of the parallel tasks happen. And with LM Studio, you can actually offset how much of the model you can send to the GPU versus the CPU. Something is very difficult to do with an Ollama. All right, resources, tools, LM Studio, Ollama. You can just install it and try it out. Models, you can get pretty much all the models on Hugging Face and LM Studio model catalog as well. What are some other resources that you can use? You can use Open Router to see how much of resources you need to run a particular model. You can try Google AI Studio, which is really, really good. You can also get a Hugging Face subscription if you're keen on trying out certain things before getting a PC or AI workstation. Google Colab is also amazing if you want to try that out. That is me. Thank you very much.
Thank you very much, Jay. That was awesome. So, what sort of useful workloads can you actually use? I mean, so you've talked about the models that you were using, but what sort of actual useful work did you get it to do?
If you're looking at running analysis of documents or trying to get other information that is probably too large for just the cloud-based ones, you can run those on it.
Yeah.
If you've got the crux becomes having a very powerful station if you're trying to train models. So if you're looking at training models, which is a very good use case, then you need a much more powerful PC or a workstation. But if you've not got that much, then you can use this for rendering images if you want. You can use this for your own research work, etc. And also there are certain models that you can run to get more answers. So if you're running out of limits on your Claude subscription or your ChatGPT subscription, or if you don't have one at all, then you can actually set this up and actually fire this as many number of times. It's not going to cost you anything. And basically, all your data is private when you're running on your own workstation. So you're not training anything else or sending out stuff that you don't want to. So those are definitely use cases that you can use. On an enterprise side, you can actually have a lot more uses, like what Lenny also mentioned, right? Generation of the marketing material, promo material, and also making sure your enterprise data is actually within your boundaries. Training SLMs. SLMs are really, really good application. So if you can create an SLM, then that actually adds to helping your own organization out. So those are just some use cases that we can use it for.
Cool. Well, any questions from the group? Go, Manish.
Thanks, Jay. That was very informative, but I think it was a bit too short. So yeah, probably a deeper dive would be great, especially on the quantization. Yeah, the quantization. What's that? Quantization bit. Yeah.
Quantization. Yep.
Yeah.
Yep. Absolutely.
That'd be great if you could do it. Yeah. Thank you, and good to see you after a long time.
Yeah, same here. Nice to see you and everybody else on here as well. Been a few weeks, months rather.
Okay, anyone else before we switch over? Okay, all right. Thank you very much, Jay, and we look forward to the deep dive.
Sure. Cheers, everyone.
So, Arjan, you're up.
Can you hear me?
Yep, gotcha, and we can see your presentation.
Awesome. All right, so my presentation will be probably slightly different than all the others because I'm more approaching AI at the moment from a philosophical perspective of how should we be using AI and how are we using AI and how could that influence the tool chain actually that we're using. So for me, I think that AI is actually not correctly used. My opinion is that we're in this situation where we're actually using AI just as a task accelerator. You could compare it with, as Henry Ford said, hey, if we ask people what we wanted, they would have said faster horses. They don't know anything else than, we have a cart and a horse. So people are using AI with AI just repeating all the things that we've done in the past. So all our problems, all our learnings, yep, it's in AI perhaps, but should we be still approaching the use of AI in the same way? To me, it's really weird that we ask AI, which is a machine, to generate code in a language that was invented for humans to be able to talk to machines, and then give that code back to us so that we can run a solution. It's a really weird situation, and to me, it's actually the wrong approach because we keep emphasizing on that AI needs to build all our solutions. And actually, solutions are not the answer to what we want. What are solutions? Solutions are based always on assumptions. Yeah, we think that if we go this way, then we will find an answer to our problem. But who is making those decisions? Hopefully together with the stakeholders, but often we engineers are actually taking control over the situation, and it's our assumptions that we're trying to apply to a solution and then give the solution to the end user, the stakeholders, and ask them, was this what you meant? Yes or no? And we're using AI in the same way. Vibe coding is exactly that. We just put in some words, our assumption how the solution should look like, and it gives us back the assumption of the model, which likely is based on a lot of bias because it's being fed information to come with that answer. That information is painted in all colors of bias, including all the wrong approaches. So why are we asking for solutions to AI if we know that that's actually not where we want to be? And even worse, solutions are often coming from the person with the loudest voice in the room. Yeah, so if it's in the example of AI, it's often hype driven. You need to do the prompts like this, you need to do the prompts like that, all to get solutions. And I think that emphasis is completely wrong. What we should be doing, because at the moment, AI is used for solutions. We should completely forget about that. AI should not be used to deliver solutions to us. What we should be doing is focusing on outcomes. We should be able to ask AI, if I want this outcome. How can you give me something back that will actually change my behavior, conditions, and attitudes? It's the same way with talking between people. When we talk with each other, we build an understanding, we build a context in which a problem domain sits, and then we're looking for reactions. Hey, if I say this, do I see a change in behavior? Does that thought, that solution, make that person happy? But it's a very uncertain way to approach things. And I think in combination with AI, we can actually get to a much better point if we start with that outcome. And why would we start with outcomes? Because outcomes are about people. Yeah, we do not create value in a solution if it doesn't change the behavior or the attitude of people. Yeah, and it is with every solution, it will actually create multiple outcomes. It will create outcomes for the stakeholders, being the customers, but also for the internal people. So often you see that outcomes create positive values and negative values, and only the sum of those are actually the value that's being created. That's where we see, especially in bigger organizations, that quickly everybody is doing something, but the overall value is negative. And it's very hard to determine that that's the case. So my approach is you always start with an outcome vision. What do I want to achieve in the form of how does this change the behavior of people or their attitude? And at the end, we will have an outcome that should align with that vision. And what sits between? Very simple. Why needs to be answered first. Yeah? Why do we have this vision? What do we want to achieve with that outcome? How does that benefit our organization, business, or personal situations even? If we know the why, then the next step is basically the strategy. What do we need to do to execute this and go towards the outcome? And the last point is then, okay, when we know the strategy, how are we going to implement this? And now comes the important piece. My thinking at the moment is that the humans should tell the why and the what. The AI can then purely focus on the how without us telling AI how to do things. So our guidelines should slowly disappear. We actually, because at the moment, guidelines is, in our opinion, what we want AI to do. But it's not true. What really is needed is context. And that's often missing. In the guidelines, written often by engineers, we end up defining how AI needs to do its work. We're not talking about the what. We're talking about the architecture needs to be this. The language used needs to be that. Why are we concerned about that? AI should be able to solve that for us. So we actually, yes, we still need guidelines because we want to have guardrails in the solution and build a protection layer in the form of guidelines, but that's the only purpose of guidelines, is building a protection layer around AI that we know that there is consistency and that there's not too much hallucination. But even if we replace AI with a human isn't consistent either. And we're still capable of working and getting things done together. So the inconsistency is not the problem. It's if the inconsistency boundaries, the margins that we have, does that fit in the context to still get the right outcome? If we have inconsistency but get the outcome, Who cares? So how does that work? And I'm going really fast here because of the time limits, but I thought, hey, this is all nice philosophical, but how can we actually translate this to the real world? And that works as follows. So what we can do is use a methodology that purely describes the what we are doing. So I'll just put some examples here. The way it would work is you define the context, the scope where you're working. So in most cases, that will be a business capability, like sales. And within sales, we need certain activities, like a store, product management, and we need an outcome for that activity. Why are we doing this activity? How does that bring us to the outcome for the business? Yeah, so actually I have one over here. Say, okay, I have resource management, and what I want is people getting the answer that we're sold out, because that influences how people's behavior will change. And how do I measure that I'm going towards that outcome? Is by defining KPIs, like how often am I out of stock? Yeah, so I'm measuring if I'm achieving or on the way to achieving the outcome. Let's skip systems for now. That's not an important aspect in this case. But so I've got a starting point of KPIs. And then I'm going to look at, okay, what activity do I need? What steps in the activity do I need to get to that outcome? And I'm actually working backwards. I'm starting with the KPI and say, how do I get that out of stock frequency? Actually, I need to have an event that has approved a purchase or has a purchase disallowed. And I'll show you some other examples later. Oh, let's do it right now. This is what I got when I did Bunnings. Yeah, so I asked Bunnings to make this context model for me based on the information on the internet. So it comes up with, okay, we need this activity and we have these KPIs. And to achieve those KPIs, something must have happened. And these are all the interactions that are needed to get the activity working. So I'm purely talking in process steps. I'm not talking about technology. I'm not talking about architecture. I'm purely talking about basically explaining the context and what needs to happen in that context. And once I've got that picture, I actually can dive a level deeper where we go to, okay, how do I get those steps? And that's what I called the outcome model, or people perhaps will recognize it as event modeling. And this shows step by step how I am getting those outcomes of interactions. But here I'm describing what the interaction actually is that is needed. Or in this case, I'm saying it's an automatic step. I don't need an interface to provide input. I already have the information based on events, outcomes that have happened in the past. So again, I'm explaining my steps in an activity without talking about any technology. The only thing that I do need to mention, as you see here, is what are the facts that are the result of that interactions? I have new knowledge. I actually have created value here because I now have a purchase order with items. Yeah, so I know what's the output, but it also means that if I need products, I actually will need something that puts products into the system. Yeah, how can I have a product list if not somewhere else products have been added? So I'm mapping all that information, go through the flow, and everything ends in independent slices that have no direct connection. They just have input events and they have events as output. And I create that as a JSON file. And this JSON object is just going into my coding environment. And I tell the AI, use this slice and implement it. I'm not telling it how to implement. Yeah, at this moment, I still am partly talking about naming conventions, that it needs to do testing, etc. But over time, AI will know all that stuff, and I don't need to give that information anymore. And the end result is that over here, without any interference of mine, by just giving it the context, I am able to run a real application where I give this stuff. This was all generated without any input of mine. And I say, okay, request purchase. It is, the purchase has been requested. And if I now go over here, it has created the events and all the information that is needed. And the only thing that I've done is providing guidelines around, this is the structure that I want. And these are the rules of event modeling. And that's it. How they code it, whatever, doesn't matter. My only real input is a context definition, which tells exactly as I'm showing here in the model. These are the steps that you need. These are the interactions that need to take place. I don't care how you implement those interactions. Yeah.
Bang on 15 minutes there.
Okay.
Well done. Very impressive what you've shown us there. Thank you. Does anyone have any questions for Arjan before I ask my own questions? Someone's got exploding claps. That's cool.
Yeah.
So it's kind of like you when you talk about the context.
Yeah.
For you, this context is this the why and the what, essentially, right? Okay.
Yeah, and nothing else. Because if you constrain it to the why and the what, you have no political discussions. Yeah, because we're not talking about how people are doing it, what their favorite tool is, what their favorite system is. We're not talking about that. We're just talking about what needs to be done and not how it needs to be done.
So would it be too simplistic or the wrong analogy? Is it essentially a business process that ends up getting defined?
It is exactly that. Even the benefits are there of it. If we take the bigger one, sorry, this one, I immediately saw here that there's a dependency between store operations,
yeah,
and the customer experience and inventory management, because at a certain point we have a store associate involved in the stock take, which means that this person cannot 100% concentrate on this business capability or this business capability. So it immediately shows you where there are dependencies, how it can interfere with each other. And it is a map of your business. It's a map of your organization of what should be done there, regardless where we are in time. The steps still need to be taken, but the technology can progress.
Go, Georgina.
Yeah, I was just like, I found that a really interesting way of looking at it, just because actually most of the time when people discuss how they're going to do it, I do want to go back to the outcome. What are you trying to achieve? What are we trying to change here? What customer problem are we solving today? But I just wanted to comment on your comment about if we remove the how, could we agree on the what and why? I'm not sure always that we would agree on the what and why. I think we would just shift our penchant to argue over what outcome we're after.
I agree in regards to the outcome. So the outcome always still will be biased. But once we have agreement about the outcome, we shouldn't need to fight about how we implement that outcome. Sorry, how we design that to get to that outcome. Yes, so the what doesn't change. We still need to do those steps to get to the outcome. But I agree, normally for me, a process like this will start with discussing a mission statement. And then you actually discover that people have hardly thought about what outcome they want. They 4% cost reduction. Okay, but if that's the outcome, then how do you actually see what changes that affects with the people that are your customers or your staff? And it could mean that you have a cost reduction for that specific purpose, but actually other costs go up because staff is losing motivation, etc., etc.
I think we run the risk in starting to talk about outcome definition, outcome planning, well-formed goals, and system thinking. I think we could be here for an hour on that one.
I think so. I think this is definitely another deep dive, and I think it touches on so many philosophical elements that we could unpack. And I think we'll move it along, and we've probably just got time for one more tonight, I think, before we wrap it up. The resume scoring assistant will need to wait until the next session. So without further ado, apologies, Manish, but the floor is now yours.
Okay, so I'm here to talk about one of the problems that I noticed when working on a project at MSc. So we were doing.
We don't have any problems. What are you saying?
We were doing an upgrade project, and we spent a lot of money in the automation testing phase. We were upgrading a product, and we noticed a lot of problems when trying to upgrade, because the upgrade had totally new UIs, it had new DOM structures and things like that. So that got me thinking about automation testing. I'm not from an automation testing background, but I did see a problem there. So for automation testing, like whenever we write any code in automation testing, we have to write code for each page that is there on like what you're trying to test. But we as humans, we don't think that way. We think in terms of intent. Once we learn how to open one door of the fridge, we know how to open the other doors. It won't be that hard. But if you're writing an automation testing script, you need to write a script for each and every door that is there. So that is where I thought, okay, need to think about automation testing slightly differently. So what I want to do was to build an intent-driven test automation framework, which I want to demo today. When I started this whole natural language and the generative AI was just coming up, and I didn't use it much. So I built a JSON-based automation test framework where we describe the intent and the automation framework in the background knows what exactly to do. But with this whole natural language processing, things have got a lot more easier, which I will demo in a bit. But the crux of this whole framework was to write your automation test in natural language, and you can execute it across products. And obviously now we have, now that I'm introduced to AI, ML, and all this kind of stuff, I was able to add self-healing features and stuff like that. So what it does is the AI layer converts into a structured metadata. Like for anyone who has worked in Terraform, like you have the HashiCorp language, where you define your infrastructure as code, and you can deploy infrastructure in any AWS or Azure or stuff like that, right? So in a similar manner, I want to, like, the idea was to build a metadata file which could work across multiple products. So that could be like in MST, we use a product called 𝗟𝗏. So it was from IBM Watson Labs, now sold to someone else, Merative, and we are transforming to Salesforce. So now for the folks who are in the automation team, they need to build the same thing in 𝗟𝗏, they need to build it in Salesforce. But here, the idea is to write in natural language and run it across platforms. So it works across multiple platforms. It uses heuristic and fuzzy selection detection. Heuristic is like, here is a landmark. It's like a landmark to guide the automation framework to locate various web elements on the screen. And it is engine agnostic. Right now I'm using Playwright, but if you want to use it in a mobile platform, you could replace the underlying layer with Appium. So this is how the whole thing has been built. So it's natural language on the top. You pass it to an AI layer. AI layer generates a metadata file, and then you have the whole automation engine. And you can just plug in products right here. You can plug in 𝗟𝗏, which is already built. We've tested this thoroughly in MST at least. We use it a lot as part of one of our projects. I've been building Salesforce into it now, trying to plug in Salesforce. It works well for the web. I'll demo on the web because that's all I have access to right now. The future is to build it for D365, and also you can add your own product. Like if your enterprise has its own product, like MST, we have different other systems, so you can add your own intents for other systems as well, right? And underneath it all, like once you build this core infrastructure, if these infrastructure cannot locate those elements on screen or cannot do the automation testing, it dives down deeper and tries to use heuristic, fuzzy, or UIED as of now, which is a user interface element detection. It's a vision-based ML. It detects that, it detects the coordinates of various elements on the screen and then tries to do whatever action you've asked it to do, right? Right now, and at the bottom, it's all built on Playwright, Python Playwright. So that is the crux of this whole automation framework. And there are a few questions, like when I presented this at MST, I got some really good feedback from the automation team and the various folks there. So first thing was, why metadata and not AI-generated code? AI-generated code, obviously, it's unpredictable. It's hard to maintain. I've tried vibe coding. It is great for demos and it works well. But obviously, when you are trying to maintain code over a long life cycle, I think it's easier when you just have to deal with plain metadata, which is easily readable. And BDD, this was another area we looked at. So behavioral, like this is another test automation style where we use a given when then kind of statement where you write like your test steps in a particular format. And then you have to write glue code. Glue code is for every screen, you have to define a model, and every action has to be mapped into your code. So if you have thousands of UIs, you'll have thousands of models, which is crazy and hard to maintain. Again, it's like you learn how to open one fridge door, but you don't know how to open the next one. You'll have to again write code for it. That's not the only problem with BDD. You'll have code quality issues. You'll have to deploy. You have to have code reviews. Someone has to learn automation. And what if there's a platform change? Again, you have to write all over again. So a lot of problems there. So this is what I have right now. So how it works is there's a selector pipeline. Like let's say I have a text box on the field with the label first name. So it tries to first locate the first name and the corresponding input box where I input my first name. If it can't find that, it does a placeholder match. Is there a placeholder? Else it tries to find based on heuristics. I'll show an example after, like in the demo. And then it does some fuzzy matching, like it's like recognizing a familiar face with a new haircut kind of thing. So an example of heuristics is like if you go to Google, there is no label. So it's hard to identify the text box unless you use the XPath selector that is associated with the text box. But for natural language, you don't want to tell, hey, this is the selector and go and find this field kind of thing. That actually defeats the whole purpose. So it is detected via heuristics because it looks for the Google search button and it probably guesses that, oh, that text box must be the Google search text box or input box. And that's how it detects it. So now, and these are a few of the future enhancements that I'm planning to do. Right now, I'm working on UID, which is a UI element. It should be UIED. So it's UI element detection. It's a pre-built vision ML, and that already detects various elements on the screen. It returns the coordinates, and then with the coordinates, your Python code can figure out what elements we are dealing with. Again, as a next step, so that would be the first step. But second step, like when you work with like very products like Salesforce or Q or any other D365, those are not like very regular web elements. So you do need to train these ML models to basically identify various elements on the screen. So the future is to go to a TensorFlow-like vision model. So this is all about this whole automation framework that I've been working on for quite a while. But at the end of it, it is one execution layer. You can handle many systems. You can have your own intents or actions that you can build in, and you can plug and play as many products as you want. Right? So I will just go over to the demo now and hope I can show some things, and I hope it works. Right? So I'll just pick up a few of the test cases that I've written. So everything is in natural language. Right? So the first one is navigate to google.com, and this is a selector that I've given, right? And then you click on Google search. So when I do a generate test, everything is in natural language. Now what happens is the AI, we provide some context, we provide how a JSON, like the metadata should be formatted, and what does it support, and all of those things, and basically generates a test. And if you look at the test, it's all in just plain JSON. And because you've said use a selector, it knows it has to put a selector right here. And now I can just run the test, and it should start executing, hopefully, and it works. So just goes here, and based on selector, it does that and searches, right? Now, if I go back here, it tells me what it did. So it went to google.com, it inputted this search criteria that I asked for, and this was the XPath selector that I used, and click on the button, and says all tests completed. Now let's take it a step further, and I'm not going to provide the selection criteria, right? So I'm going to provide the actual XPath to it. So I'm just saying use this as search criteria and generate test. And now there is no selector defined here. So what happens is now it has to actually, if I go to google.com, obviously there is no label on this, right? So if I run test, what it does, it uses heuristics, like it looks at the button that is there, the big Google search button, this Google search, and assumes that that is the text box, and then finds that. Okay, so actually, sorry, so just, why did it generate that? Okay, let me try it again. Right, okay, so this is, yeah, this does not have the selector. It just has the input text and there's no selector. Now if I run it, right, so now it ran. So if you look at it, it says navigate to google.com, then it says it's self-healed because there was no way to actually identify the text box. So it used some ways to figure out that, okay, that is the box where I need to input the data. And then we clicked on Google search and it passed, right? So if I look at this, it tells me actually what happened. So it could not find the exact match for that step. Now I'll take it a step further now. Let's keep going. I'll go to agentics.org, right? So now this is probably a more valid scenario. Like I'm saying, do all these steps. Go to Agentics, page for wait for the page to load, validate that the title contains this, and verify this is heading is displayed. Take a screenshot, click on this link, and do all these things, right? And then click on the contact. What I want, click on contact. I say click on the Hello World button. So now if I do a generate test, so now again, it interacts with the AI and generates a metadata file, which again can be run, and it's going to do everything just fine. So it says, yeah, there are 21 steps, and I can run test again.
Manish.
Yep.
Are you able to demonstrate testing anything other than a website?
Like?
Some other piece of software?
So we've tried it in MSD actually with the CMS product. So we've used it also in our projects. The traffic light system that went live. We've used it there extensively.
Yeah.
But obviously, I did not use the AI layer because we don't have access.
Yeah, sure.
Right. But what we did is we can also handcraft these metadata.
Yeah.
With handcrafting, it gets even more extensive. Like you can actually declare variables. You can save. It works like a little mini programming language itself. You can combine multiple files into one, like multiple tests into one, and run them as a chain. So you can do a lot more things.
As you were showing us this, I was sitting here thinking, what is this all about? Like, why is he doing all of this stuff? And then it just kind of clicked, and I realized, like you're actually using this to test the software. So any software that you have,
yes,
you just write natural language, the steps that you want it to do, and then it will create essentially the script, and then go off and do it. Yep. And then come back and tell you the results. Like the software that I'm making or the change that I've made in the software, it will do the tool test. It's pretty clever, man. Like that's pretty impressive what you've built here, mate.
Thanks, Chris. So look at this one. So this has 21 steps. So it passed all of them.
Yeah.
But the last one, it said click on the button Hello World.
There's no button.
Yeah, there's no button called Hello World. It's called send. And I don't want to send emails. I've been testing it on the Agentics org website quite a bit. But yeah, so it passed all the tests and it just failed the last one. But then in my test case, I had said, click on the trainings, verify that the navigation menu contains trainings. But actually in the Agentics, if I go, there is nothing called training. There's training with a singular.
Yeah.
But here it is training. So it says that it's passed,
fuzzy.
But yeah, it's a fuzzy match kind of thing, right? So it gives you all this thing. So basically what we are seeing here is that we are just writing in natural language and you are able to automate test entire websites. Right. Now, I'll just do one last one. And this one is a website that I use frequently to do some testing. So this is a cosmetic website, and so you can add to cart, remove from cart, and stuff like that.
Yeah.
So if you look at it, so what we're trying to do is we are going to this website, we are waiting for page to load, we click on products, we validate that this exists with the price, and then we click on the product and click on the plus button. We validated the quantity is 2, then click on the minus button and validated the quantity is 1, and then click on add to cart and validated the total price is 1379, and then click on proceed to checkout. So this is what we are trying to do. So we are trying to add to cart, we are increasing the quantity, reducing the quantity, validating all of that, and then checking the price. So when I do that, now it goes ahead again, generates a metadata file, which is used by the underlying automation framework. Not sure why it's taking time, but it's usually pretty quick.
The demo gods.
Yeah, the demo gods.
I'm not overly familiar with test automation in general, but would I be right in assuming that normal test automation frameworks aren't actually automating the creation of the tests? Like it's just running the tests and giving you the result. Is that right?
So in test automation, like we do have to write code, right, to actually automate the test. So you have a whole life cycle, similar development life cycle and deployment life cycle for those automation tests. So the automation, usually what happens, at least from what I know in MSD, is that we are in a project, and towards the end of the project, we'll involve the automation team and tell, okay, our product is stable now, can you automate it for us? And then they go ahead and write their code and write some like 10 or 15 scenarios to basically validate the flows.
So essentially, if I'm not mistaken, what you're doing is actually test automation.
Yes. Yes.
Yeah.
So basically, sorry, but test automation is out of the picture now because it's all natural language.
Exactly.
And there is no test automation as such.
That's right. Yeah.
Right. And there was another thing, like when we did the upgrade, when we did a 𝗟𝗏 upgrade, we had the accessibility team also actually trying to see contrast, like how does the software work, like for low vision users and things like that. So already, like we have vision-based models, we can actually do the accessibility test and all that for us already. Yeah. So in this generated file, by default, it's turned off. But if I turn it to true, then it actually does accessibility testing for each and every page that we are in. It tells you how the page contrast is, if there's an image overlay, whether the text and the contrast ratio meets this is WCAG guideline, which is a European standard, whether it meets those guidelines and things like that. But for now, I will just run this first, where we actually do the, so it's generated the script, and it goes to this website, and you'll see a few flaws here. So here, it loads an image, and then you can barely see these menu items, right? That's right up there. So it goes here, but still, we still want to, once the page finishes loading, it goes to the products. It clicks on the cooling water jelly tint, checks the price is right. Then it goes and actually increases the quantity to 2, and then decreases it back to 1, and then it does add to cart, and then it tries to validate the price, which is $6.99. But here in my test case, I've said, check if the price is 1397. So that test should have ideally failed. And here it says, validate if total is 1397. But here it says, actually it found 699. But you've said in your test case, it should be 1397. So we have actually automated the whole sequence just by a few clicks. So now, if I actually do the same thing and just change the accessibility check to true, right, and then rerun this again, you will see that it actually does some OCR checks in the background. So it tells that the contrast for your navigation menu is really bad. It should be, the contrast ratio should be 4.5 according to European standards, but yours is only 1 or something. It's like really, really poor. So low vision users will never be able to use your website kind of thing. So yeah, it does all those checks. So yeah, and I will just show the final report that it generates, and we should be done. Right, so that is it. And as part of the, so there are 27 OCR violations, text over image. And if I just go here, actually it generates it into a JSON file. And if I just go here, it'll tell you what are the violations. So the contrast is 1.79, but it needs 4.5:1 kind of thing. So that's what they do in the accessibility testing.
This is awesome.
Yep. So this is what I've been doing with AI for some time. And
what are your plans for this?
I actually presented it to MST a while back, and like I said, we use it in the product, in a project, but I had not showcased the AI layer at that point of time because I did not want to. But yeah, probably I'll bring it to the architecture forum and we can see what to do from there.
No, but I mean, so you've developed this. Is this something you want to market, or is there a product here?
I believe there is a possibility of a product because yeah, I think it's I like it personally, seeing all the challenges and the cost actually for automation testing, especially when there's a transformation project or whenever there's a major UI change. I did see that there's a lot of cost involved. Like when we did the last QM upgrade from V7 to V8, we must have spent like 6 months on testing, manual testing. And that is a lot of money with 5 testers. So, but if you had automated, like we take the whole Excel sheet that is there, the whole suite, and we just feed it to this, and it generates a test for you, it runs it for you. You're saving a whole bunch of money, not just money, you're saving time. And yeah, there are better things to focus on. Your upgrades will be faster. So it brings about changes a lot faster.
Even if it was just the website testing, like even if you just went to market with a website testing tool, you know,
right.
you would have something. That's pretty special, man. You should be proud of that. Great job.
Thank you. Yeah, and that's me.
Does anyone else have anything they'd like to ask or say to Manish? No, they've just given you lots of emojis and hearts and claps and stuff.
I'm also really impressed, Manish. The one thing that I would say is, if you want to productize this, look at what mode you can build around your product. How likely is it that AI actually is taking over this functionality, or do you clearly see that no, you need a very deterministic framework around this to be able to do this, so AI will not be an immediate danger for your product?
Right. What I see is automation testing, we want it to be deterministic. We cannot have it non-deterministic, most cases. So while AI might do most of the work, but AI is non-deterministic, right? So that is one of the big challenges. So that's why the framework layer, I believe it should try to do most of the work. And if it can't do it, then you have those ML layers actually, which is trained on the specific product. And I feel that would be a better approach than trying to let these LLMs take over and do it, because that wouldn't give a, like, at least from a product perspective, it might not really work. Yep.
Okay. Well, that's probably all we have time for this week. I've just chucked in the link to the chat if anyone would like to keep talking. We have a ongoing conversation there in WhatsApp, and I will edit this a wee bit, and I'll be sharing the recording as well at a later stage. And apologies if we didn't get to your talk this week. We will do it at the next one. So look forward to hearing about the resume scoring assistant. Jerry has some cool stuff he's been doing with YouTube, and keeping track of all of his learning he's been doing there. We also have another test automation framework. Okay, that'll be interesting. We can have a bake-off. And Blair has been doing, I made it intentionally sound very, very impressive, a meta persona form-filling agent, again, for test automation. So thank you very much, everybody. Go off and enjoy the fireworks. I've certainly been hearing some in Lower Hutt. And yeah, maybe, I don't know when we'll have the next one. Depends if we get a whole bunch of people who want to share what they've been up to, and we have a big list, then maybe we can do another one in a couple of weeks. But otherwise, probably a month from now. Okay. Never mind. We will see you at the next one or on the chat. Bye.
Thank you, Chris. Thank you for the invite.